simplify the rational expressions. So before we can simplify, we need to factor. This numerator is a difference of squares, so it factors x minus 1, x plus 1. The denominator has a GCF of x squared, so I can take an x squared out of both of those terms, and then I have an x minus 1 left over. A couple of mistakes I saw on the quiz is thinking of these terms as individual factors. So like thinking of this as x times x times x, and then x times x, and then somehow canceling this with this. And that is what we call killing a puppy. So we don't want to do that. So you want to factor, always look for a GCF first. And then if you've got a GCF, pull that out. And then if there's not a GCF and it's a binomial, try perfect squares. If it's a trinomial, try the x box. So our x minus 1s will cancel here. And then I'm just left with x plus 1 on top and x squared on the bottom. Okay, on the next one, the numerator is just one single term. It's all multiplied, 7 times x times x times x. The denominator has a GCF of 14x. And when I factor that out, my first term, I'm left with a x. And my second term, I'm left with an 8. All right, so 14 is 2 times 7, so I can cancel those 7s, and then x to the third is x times x times x, and I can cancel a pair of x's. So now I'm left with 2 x's on top, and a 2 and x plus 8 on the bottom, or you could have answered it 2x plus 16. You could have distributed that 2 there. Okay, with multiplying and dividing, it's a little bit more of the same. So you want to factor first and see what cancels, and then after you cancel everything, you want to do your multiplying or dividing. So this first expression, x squared minus 64, that's a difference of perfect squares. So it's x minus 8x plus 8. And its denominator is just 7 times x. And then this numerator is 3 times x times x times x. And I'm going to go ahead and write that out. And then the denominator of that one, we can do the x game to figure out. So something that multiplies to give us negative 72 and adds to give us positive 1 would be 9 and negative 8. And then we would have x squared, 9x, negative 8x, and negative 72. So we have x plus 9 and x minus 8. And the x minus 8s would cancel. And then one of these solo x's would cancel. So now in the numerator, we've got 3 times x squared times x plus 8. And in the denominator, we have 7 times x plus 9. So we have 3x cubed plus 24x squared and 7x plus, what is that, 63. Okay. Same for this one, except that it's division, and to divide two fractions, you flip the second fraction and multiply. So we changed our division to multiplication, and we flipped that second fraction. Now this first expression, there's nothing to factor, it's just x minus 5. Same for the x minus 7. And then x squared minus 49 is a difference of squares. And then x squared plus 2x minus 35 is going to be positive 7 and negative 5. And you can do the x game and figure that out. You've got to multiply to get negative 35 and add to get 2. That's going to be a positive 7 and a negative 5. And then here our x minus 5 and x minus 5 can cancel. Our x minus 7 and x minus 7 can cancel. And x plus 7 and x plus 7 cancels. And what does that all reduce to? When everything cancels out, it equals 1, because each of those factors, when they cancel, equals 1. And the last section is adding or subtracting, and in order to do that, you have to get a common denominator. So this denominator has an x, this denominator has a 3x, so what would be common is 3x. So we'll need to multiply this first fraction by 3 to give us a common denominator. So that would make it 27 over 3x minus 5 over 3x. Now that we have a common denominator, we can just subtract 27 minus 5, which is 22. Okay, the second one, we would need to factor this to figure out what the common denominator is going to be. So to factor it, we've got negative 15x squared and negative 2x. So what multiplies to give us negative 15 and adds to give us negative 2 would be negative 5 and positive 3. So I've got x squared and minus 15 and negative 5x and positive 3x. So that's x minus 5x plus 3. Okay. So both denominators have an x minus 5, but only one of them has an x plus 3, so we'll need to multiply this by x plus 3. And then we would have x plus 5 over our common denominator, and 1 times x plus 3 over our common denominator. And then we can add those two together, so we would get 2x plus 8 over our common denominator.